Good afternoon and welcome to the Independent Sage briefing. The pandemic is not over. It's still a public health emergency of international concern, according to the WHO. We've got a new variant called Arcturus, a subvariant of Omicron doing the rounds. It's caused a surge of infections in India, and it's also found here in the UK. So we've got to think still about precautions against the spread of this virus. And in the spirit of that, I'd like to make an announcement. The COVID Pledge Group and Clinically Vulnerable Families Group have now launched a pledge called the Campaign for Safe Healthcare. Now, they've produced a template letter and a fact sheet with the support of Doctors in Unite, the union, the Hazards Campaign, and Independent Sage to help people to request safer care. And copies of that letter and the fact sheet are available on the COVID Pledge website, the link to which is on our Twitter as well as the YouTube stream. So we look forward to your support and participation in this initiative. Today, we're going to look at the latest evidence and literature on a number of COVID-19 concerns. Our panelists will provide their expertise and reading of the recent research on topics like vaccines during pregnancy, drug resistance, long COVID, among other things. But before we get to that, I'm going to invite our Duke of Hazard, Dr. Duncan Robertson, to give us a presentation of the latest numbers and trends. Over to you, Duncan.
Thank you very much, Anthony. So I suppose this is, we're starting to go into the sort of regime where we have less data, particularly the ONS survey. So that was paused at the beginning of the month. So we do have some data available, and we can think about how we can look at the number of people who would test positive, not in such a good way as the ONS survey, but we can use PCR test positivity, which is about stable. Hospitalizations, but apart from that, it's a fairly good news day. Hospitalizations are decreasing, occupied COVID beds are decreasing, and mechanically ventilated beds are also decreasing. But we still have pressure on the system. Ambulance response times are still well above target. And we haven't yet seen in the data people getting their spring 2023 COVID booster campaign. So we're still at the stage where we have relatively large times between now and when people had their last COVID booster. And we're just starting to see COVID mentions on death certificates fall as well. So a relatively good news week. So positivity. So before, up until now, we've used the ONS COVID infection survey, which takes a representative sample of people across the country and sees whether they would test positive for COVID. And of course, as the government's moving towards living with COVID, that survey has been paused. So we need to look at other ways of finding out roughly what proportion of people would test positive. Now, the data we're going to use is positivity, PCR test positivity, which is the number of people who test positive on a PCR test divided by the number of PCR tests that are reported in a week. Of course, this isn't representative. You're most likely to get a PCR test if you're in hospital and potentially show symptoms of COVID. But, it's all we've got. So that's what we're going to be using. So this is as a result of this change in testing approach. So this is, from 1st of April, changes in testing have started. So as well as the ONS survey, there are moves towards how testing in the NHS is taking place as well. So kind of comparing it over time is more difficult at the moment because we're going from this regime where we have this representative sample to where we have just PCR tests being reported. And so this is the test positivity for England up until, and one of the other issues with this data is it's relatively old. So this is up until April the 10th, but this is what we have. And as we can see, roughly 10% of the tests or 10% of the people taking PCR tests would test positive. And we're sort of seeing that relatively stable with some ups and downs over the last few months. But you can see here the number of tests is decreasing as well. So as well as lateral flow tests, PCR tests are decreasing. So we're going into this regime where we have worse data. But hopefully we're still going to have some data which gives some idea of what the virus is doing. In terms of hospitalizations, we have a downturn in the number of people being hospitalized for or with COVID over time. And of course, some of this could be caused by changes in testing procedures, but I think it is, on the face of it, good news. And this is hospital admissions splitting out under 65s and over 65s, and both those are coming down. So, we're in this sort of regime where things have changed on the 1st of April. So hopefully as we go forward, we'll have better data, more consistent data from the 1st of April. Occupied beds are decreasing up until the 19th of April. So good news. And also most severe cases, mechanically ventilated beds are also decreasing over time. So good news there. But of course, there is still this pressure on the health system. If we look at ambulance times, these are the most severe cases, severe calls. And as we can say, as we move into 2021 and into 2022 and into 2023 now, we're still seeing the targets being missed for ambulance times. And in the last couple of weeks, that's getting a little bit worse as well. So not good news there. And this is for C2 calls, which are category 2 calls, which are less urgent, but still require rapid assessment and or urgent transport. So they're still being missed in terms of the targets there. So there is this pressure on the health service that hasn't gone away. In terms of vaccinations, this is looking at how long it's been since you had your last COVID vaccine or COVID booster. And as we can see, that green, dark green line at the bottom is getting less and less as we find the campaigns are further and further away. So we're starting to go into the spring 2023 COVID booster campaign. So hopefully in the weeks ahead, we'll see that dark green line increase over time. But of course, not everyone's eligible for those COVID boosters. And this is looking at the last few weeks. So we have, basically everyone is more than 3 months from their last COVID booster. And just to talk about that COVID booster campaign for spring 2023. So it's eligible, people who are eligible are over 75, or you've turned 75 on or before 30th of June 2023. Or you live in a care home for older adults, or you have a weakened immune system. So that's the category of people who potentially will be getting their COVID booster. So just to say that is starting now, essentially. So you should be able to go and get your booster when called. And finally, deaths. Unfortunately, deaths are still occurring. This is looking at COVID-19 on the death certificates, relatively old data up to the 24th of March there. But in the most recent data as well, we're hopefully starting to see getting over that hump and deaths decreasing. But still, COVID hasn't gone away. And there are still deaths occurring with people who have COVID. So as I say, in summary, we're moving from this regime where we had an excellent information about who had COVID, the ONS survey, that's paused, and we're looking at other ways of measuring the amount of COVID in a population. And so we're looking at PCR test positivity, and roughly 1 in 10 people who have a PCR test that's reported test positive. But apart from that, relatively good news: hospitalizations decreasing, occupied beds, mechanically ventilated beds, and deaths are all decreasing, which is good. Ambulance times are still well above the target, and we're just about to go into the spring 2023 COVID booster campaign, but we haven't yet seen that come through in the data. So that's the data for this week.
Duncan, thank you so much. That was great. I guess we should expect things like hospitalizations and deaths to fall if we're doing much less testing, because GPs simply won't know whether they've had COVID or not. But that's just one comment. The other thing is, I note that it's over 75s that will be offered a booster. In the United States, they're giving it to over 65s. And I think that's the case in Europe many parts of Europe as well. But we will come back to that. But I'm going to hand over now to Professor Sheena Cruickshank and Dr. Stephen Griffin, and they're going to go through asking a whole number of interesting questions, and we'll see what our experts have to say. Over to you.
Thank you, Anthony. So all of us in Independent Sage, we either do research in COVID, or at the very least, we keep up with all the latest developments in COVID and related research. So what we thought we'd do today is something a bit different. We were going to share with you some of the latest breakthroughs and findings that have been catching our attention. Steve, I'm going to start with you because I believe you've been seeing some really concerning stories about drug resistance and COVID, and also what this might mean for NICE guidelines.
Yeah, thanks, Sheena. So the relevance of what I'm about to talk about very briefly is in light of the recent recommendations or draft recommendations that NICE made pertaining to those antiviral therapies that especially vulnerable people are given very, very early on during infection. And of course, limited testing is going to impact upon this as well. Basically, we used to have a whole array of these monoclonal antibody therapies. We now have one left, really. And we also used to have several antiviral drugs, direct-acting small molecule antiviral drugs, which we've spoken about on this before. So we had remdesivir, which we heard about all the way through the pandemic, which is unfortunately given intravenously. Then there's molnupiravir, which was made by Merck. And there's also Paxlovid, which is probably the most famous. Now, NICE have recommended that we only keep Paxlovid for giving people these short-term early antiviral interventions for treating people to stop them becoming severely unwell and going into hospital. And Paxlovid is used far more widely in the States, for example. And one of the implications of using one drug on its own with a virus that's highly variable is that that virus may eventually generate what we term resistance. And that means that the protein, which is the target of that drug, in this case, the viral protease, changes its composition so that drug no longer binds and is no longer effective. So there was a study published in Science Advances, which is a really nice, reputable journal. It was from the lab of Reuben Harris. And what they looked at is variants of the virus which are already circulating. Now, that's important because we know that these resistance profiles are easy to generate in the lab, but there haven't been much evidence of any of them circulating at the moment. But what they found was that there were several different variants of this virus that are already transmitting and are resistant to Paxlovid. But it's not all bad news, because they also looked at a different drug, which is just about coming onto the market, made by Sheena, which also is a protease inhibitor drug. Okay. And the interesting thing about that is that you did see resistance, but the pattern of resistance was different. So what that means is that if we could broaden the repertoire of drugs that we have available, then there's scope for using combination therapies. And those are good in two ways. One, they work better, and two, they suppress the incidence of those resistance mutations happening. And we could also go back to these ones that NICE have got rid of for the time being and look at combination studies with them. So hopefully that's going to be the future of these antiviral treatments for patients in forthcoming years.
That sounds really important, actually, and the kind of thing that I really hope people are going to pay attention to, so that we can actually see these measures come into being. Now, there's also been some really big findings into some risks of autoimmunity, I think, following COVID, I believe, Danny. Can you take us through them?
Yeah.
You're on mute.
So, yeah, am I okay now?
Yep.
Yeah, so it's been a busy time for those kind of data sets, because I think in long COVID, we've had a bit of a disconnect sometimes between talking about the normal, so-called, now normal long COVID persistent symptoms, and then big new diagnoses of autoimmune diseases and things like that, whatever. And in a sense, those are all consequences of your COVID in the long term. So for me, they're right in there in the long persistent cysts. And there've been some big data sets coming out in the last few weeks, the kind of things where you take national regional healthcare and you compare people who've had a PCR positive COVID infection and people who haven't, and you look at the hazard ratio for getting lupus or vasculitis or diabetes. So one that we're all very keen on is a paper by somebody called Chang.
Danny, you're breaking up a bit. Could you switch your video off and then we can hear you?
Am I any better now?
You are much better now.
Okay, and better not to look at me anyway. So it's one of the Lancet journals, and so there, in large healthcare record data set, they're reporting hazard ratios twofold for vasculitis, threefold for lupus, 1.85 for inflammatory bowel disease, things like that, and then a separate study from Canada healthcare records. Published in one of the JAMA, Journal of the American Medical Association network journals, where they've combined type 1 and type 2 diabetes in their analysis. So, if you like, autoimmune and not so autoimmune, and have a 5% excess burden for the people who've had a COVID infection. So, lots of stuff like that on our minds at the moment in terms of trying to kind of decode what on earth is going on and just kind of expand our thinking about what on earth is going on in long COVID. The only other things I'd chip in terms of on the kind of long COVID bullet points at the moment is quite a lot of discussions in different countries about their kind of divergent approaches to long COVID care and management and healthcare provision. Some countries, Finland springs to mind, really not really recognizing it at all. So a lot of discussions about things like that, and just I think a lot of uncertainty amongst long COVID researchers at the moment in the UK that all of that kind of first tranche of research funding is kind of drawing to a close now, and shock horror, it hasn't all been solved in the last 2 years. I mean, we now need the really big studies to carry on, and it's not really clear that there's enormous buy-in to more long COVID studies. So I'll leave it there, but those are my kind of long COVID news flashes.
Thanks, Danny.
That's quite worrying.
There's obviously a lot more to long COVID than we thought.
I was just going to ask a quick question, because I remember a paper came out a few years ago, and I think it was the herpes simplex virus, I think, or maybe it was Epstein-Barr virus. They showed that it was interacting with risk loci for autoimmune diseases, and they were seeing a similar increased risk. Do you think that's a sort of mechanism that we might be seeing with COVID for how it's interacting with sort of risk genes? So polymorphisms in our genes. So this is where you've got changes in expression of genes.
Well, I mean, so many sort of hypotheses on the table at the moment, and one of our beloved hypotheses, virus reactivation has been quite strongly implicated in some autoimmune diseases like MS, somewhat less so in others like lupus. And we have notions on the table about how that could work. So again, it's just a kind of, well, I was going to say it's a work in progress.
Okay, thanks. I think we've lost Danny there.
Sorry.
No problem, Danny. I mean, it's a really fascinating subject, and there's a lot of literature out there if anyone's interested. As I said, long COVID's not just your standard symptoms that you might hear about. There's all these predispositions to what you might term latent complications that are happening, and that really does sound troubling in terms of long-term duress on the health system. But
Steve,
going to continue.
Sorry, just on some of those risks are associated with quite rare conditions, but diabetes is incredibly common.
Absolutely.
And we've got 1 in 20 people added to the numbers. That's going to have a very big impact on the health service, on drug spend, on morbidity, on shortening lives and the rest. So I think that's something that really needs to be followed up very carefully, if that is true.
I agree. And if you think about the healthcare system in America, where they have to pay for their insulin, for example, that's going to be a major problem, isn't it? But I think we should carry on with the immunology theme now. And you may notice I've jumped in where Sheena was speaking, because we're now going to ask Sheena about something. And that's mainly about the real potential of these new mRNA-based vaccine platforms for multiple different diseases in terms of making new vaccines, Sheena. It really is powerful, isn't it? Tell us what's been going on.
It really is powerful, and there's been some huge developments in vaccine trials. In fact, even some that the news was just breaking today. But I'll start with RSV. So this is a virus that many of us will have had, and it really affects the kind of extremes of age. So the highest burden of disease is in the very, very old and the very, very young, particularly those under the age of 6 months. And a vaccine that will treat the virus has been quite elusive since the virus was first discovered in the 1960s. But now we've got not one, but 2 RSV vaccines that are applying for licensing. And these have already gone through phase 3 trials. They are mRNA vaccines, and they've been shown to be protective for older people. And they've also been shown to have an important role in pregnancy. So in a phase 3 trial, babies who were born to mums who were vaccinated during pregnancy were protected from RSV with an efficacy of around 82% at 3 months of age. And that's one of the age groups that are the most vulnerable to the bad effects of RSV. And mRNA vaccines have also been hitting the headlines again with new research that's revealing their potential for delivering personalized vaccines to target cancers. It's melanoma that was in the news today. And this has been shown in a clinical trial to have resulted in clinical remission for 84 out of 107 patients. And what was really exciting was this seemed to be quite durable. It was lasting up to 18 months. They've just tested them again, and a lot of the patients were still in remission. And I guess as this technology continues to be developed, I've got a really, really big concern, and that's around vaccine disinformation, because a lot of the vaccine disinformation is around mRNA vaccines. And so this could really impede both the kind of the take up and sort of ability to really make the most of these applications. And then there's also some really big news in the States as well, because what they've done is they've just announced a really big investment into COVID vaccines. These are going to be a lot more long term, and hopefully it's really about thinking big, it's thinking long term, it's thinking, what do we want to do? Do we really want the annual boosters? And I know this is something you've heard me and Danny muse about several times. So what they're looking at is developing vaccines to try and target multiple variants of vaccines, so multivariant vaccines is the sort of term, and or blocking vaccines. And they're particularly interested in what we call mucosal vaccines. That's things like inhalable or nasal vaccines. So I've already written about the need for these types of vaccines before in places like The Conversation. And I really hope that we see some similar sort of long-term strategic thinking and investment in the UK. And interestingly, the British Society for Immunology have just put out a document aimed at policy. And this is about the considerations that we should be thinking about for vaccine research, pandemic research, such as the need to evaluate vaccines in clinically vulnerable people, the need to have such groups and other groups of patients involved in vaccine research, and a need to assess the immunogenicity. What are the markers of protection? What are the long-term markers of protection for vaccines? So there's an awful lot happening in the space of vaccines.
That really is incredible, isn't it? I think the capability to mix and match these mRNA vaccines is just incredible. There are lots of tumor immunology vaccine studies that have tried to do that sort of thing in melanoma, but I've never heard that level of success rate in terms of remission. That is incredible.
And it's the way that they were able to use sort of something like up to 38 unique features of people's tumors. So they're really being tailored well. And often they're being used in combination with checkpoint inhibitor therapy, which is another kind of immunology innovation that really helps and sort of transform the ability of T cells, our white blood cells, to be able to kill tumors.
Oh, absolutely. That's absolutely fantastic. And as you mentioned, this whole idea of misinformation and sometimes outright disinformation that we discussed a few weeks ago, actually, really is rife with mRNA vaccines. And what would be absolutely criminal is that if that sort of thing was to negate from the utilization of these things for the greater good of public health. Of course, no medicine is perfect. People do sadly have very rare adverse reactions. We need better support for that. But when people start saying that all these things are widespread and causing people to drop down in football pitches, I think that really undermines the cause for people who are actually suffering with these vaccines. But talking of disinformation, Professor Greenisle knows a lot about getting rid of disinformation and debunking it. And she's found a particularly interesting story about another evil aspect of mask wearing. Trish, tell us.
Yeah, well, the question that this is about is, do masks cause long COVID? Now, there's a new paper doing the rounds on anti-mask social media. That paper, it's been distributed very widely. It has been published in a peer-reviewed journal. So technically, it's an academic paper, but it's not a paper I'd recommend you read. That paper claims to have shown that long COVID is the result of wearing masks. In fact, the authors have renamed long COVID mask-induced exhaustion syndrome, or MIES. So what they say is that people who wear masks are depriving themselves of oxygen, they're rebreathing their own carbon dioxide, which all builds up over time and somehow produces all the symptoms of long COVID. So what is this paper? Well, what the authors did was something called a systematic review and a meta-analysis. So there's lots of numbers and statistics in it. They found 54 research studies, each of which have been written up in a different paper. And each of those studies compared people when they were wearing masks and when they weren't. Now, the bottom line is that the authors of the systematic review didn't really show any link whatsoever between mask wearing and long COVID. And as Gideon Meyerowitz-Katz said in an excellent blog on this paper, it has got major flaws. And I'll just tell you a couple of them. The first flaw is that not a single one of those 54 studies looked at whether anyone got long COVID. The average duration of mask wearing that was examined in the studies was 18 minutes, which is a bit short considering you've got to be unwell for at least 4 weeks and probably 12 weeks before anyone's going to say, yes, you've got long COVID. The second flaw is that the reviewers started off looking at masking in everyone, but then halfway through their review, they changed their protocol to look only at mask wearing during moderate or severe exercise. Now, this is known as a protocol violation, and you're not allowed to do it. Now, I've done a review myself a couple of years ago, and that showed that unless people are exercising very heavily, physiological parameters don't change significantly when you put a mask on. The third flaw in this systematic review is that the authors made literally dozens of very basic mistakes in extracting the numerical data from each of those 54 research studies. They literally copied numbers from the wrong columns, or they selectively picked out only the numbers that made the masks look bad. So, for example, there was one paper that compared 4 different kinds of mask, and these systematic reviewers pulled out data from one kind of mask for oxygen levels, another kind for carbon dioxide levels, and a third kind for heart rate. Now, that's not science. So, fourthly, even in people who were doing heavy exercise, the differences in the physiological markers between wearing a mask and not wearing a mask were tiny. For example, blood pressure differences were around 2 millimeters of mercury different. And that's not something your doctor's going to get excited about. And it's certainly not something that's going to give you long COVID. Finally, because not all of them, but nearly all of the included studies used what was known as a crossover design, they proved that all the physiological differences, which were minor anyway, immediately went away as soon as people took their masks off. So the bottom line is, long COVID is a rotten disease, but it's not caused by masks.
But thanks, Trish, for that. And I think debunking is so important, and trying to sort of get the right message out there. And sometimes that can be hard in the noise of misinformation and disinformation. But another hot topic, talking of misinformation and disinformation that we've been seeing a lot about lately, is the developments in research into the origins of COVID. Steve, what's been happening?
Thanks, Sheena. Yeah, so I'm not going to get into the politics around this because there's some debate around when this sort of data should or could have been released by China. But the fact is that a few weeks ago, some more data was released pertaining to the very, very early sampling studies that they did around the Huanan market, which is in Wuhan in China, where many people feel that the pandemic almost certainly started, or at least jumped into humans. A few weeks ago, maybe a few months ago now, we also had this evidence-based discussion around that in terms of the evidence around where the virus was found in the market. There's been lots of epidemiological studies in people, but what's been seen recently, just published in Nature as an early access paper, is that where they were finding viral sequences, they are now also finding animal DNA, particularly mitochondrial DNA, which allows you to type what these animals are. And a lot of it is associated with one particular species of animal called raccoon dogs, but some others, things like civets and things like that. And they are well-known harbors of these viruses as what we call an intermediate host. So we think it originated from bats, goes via this intermediate host and jumps into humans. Now, it's not definitive. This is still associative. We're still finding things in the same place, but there were some places where there was just SARS-CoV-2 and animal genetic material and really no human, which does suggest that there were at least animals that were infected present in the market. But the other really important thing is that one of the big arguments that people have used to sort of bash the idea that this jumped over in the market is because right at the beginning of the pandemic, there were two sorts of SARS-CoV-2 circulating: lineage A, lineage B, imaginatively named, as you might imagine. Lineage A is ancestral to B, and they could never find A at the wet market, but now they have confirmed that they did find A at the wet market. So that suggests that these emergencies happened probably over a span of time, but they did seem to happen at least geographically in the same place. You can't say for sure it wasn't a person bringing it in, but it's just adding to that weight of evidence that, you know, genetically at least, this virus is definitely present where animals were being sold in that market, and that feeds into all the other epidemiological things. And it also detracts from the idea that there were more than one laboratory leak from the Wuhan Institute of Virology, because it would have had to have happened twice to two different strains of virus, and that makes it even more remote. So really interesting, but it's really hard to find the actual ancestors of these viruses. So many bat species, so many different viruses. It took over 10 years to find it for the first SARS. So, you know, keep watching, but it's a very important development.
That is really compelling evidence, isn't it? And we're going to just move into a different topic now, because I think, Kit, you've been looking at some of the data that we get from the actuaries, and you've got some sort of observations about what we can do with that data, what we can learn about that data.
Yeah, absolutely. I'm just going to share my screen briefly, because I want to just pop up a couple of slides. These sorts of slides that we show in the data quite regularly about NHS key performance indicators. They come out once a month. The last time was on the 13th of April, and they show data up to March. So this is just looking at A&E waiting times, and you can see that they have they've been going up consistently since 2010, but actually significantly since the pandemic started, particularly post summer of 2021. We can see these big spikes, and we're seeing 29% of people who come to A&E are waiting longer than 4 hours from arriving to being admitted, and that amounts to about 550,000 people. There's a slightly more stringent measure we also look at, which is how many people are waiting from decision to admit, so when they've been seen by someone and that they've been decided to be admitted, and then to being admitted. These are so-called trolley waits. So again, this is 27% of people who are being chosen to be admitted, and that, again, this constitutes now 144,000 people. And actually, by the same metric, people waiting longer than 12 hours. That's around 40,000 people. Now you can say, well, so what? Big deal. What does this matter? And I'll let me just stop sharing my screen for now. You say, what does this matter? You know, these are just targets. It sounds bad, but is it actually having an impact? So this is where I've looked at some of the research that the COVID Actuary Group have been doing. They've been working really hard over the course of the pandemic, looking into all sorts of questions, but in particular, they've looked into this and they've estimated the number of deaths that are attributable to these long waiting times in A&E. That's not to mention other delays throughout the NHS. This is just these acute delays in A&E. This is not to mention ambulance waiting times, etc. So to do this, they looked at a study in the Journal of Emergency Medicine, which associated delays in emergency admission with all-cause mortality. So they said how many people need to wait, if they're waiting for 12 hours, say, how many people do we need for that to translate into a single death, if you like? And so what they can then do is say, well, we're having this many people waiting for longer than 12 hours, 144,000 last month, and then they can calculate how many deaths that would translate to. So unsurprisingly, this study found that longer waiting times were associated with higher mortality rates. And so when the actuaries have gone and done this calculation, this is for data actually from the end of last year, they found that roughly from September to October, we were seeing about 500 additional deaths a week due to these waiting times. And that's actually a conservative estimate because they use this trolley waiting time rather than this arrival to admission waiting time. So that's just one figure. You can see from the charts that I showed you that those figures have come down a little since their peak in December, but they're still exceptionally high. So we are still seeing high levels of unnecessary deaths due to these long waiting times. So I'm sorry to be so depressing about that, but that's the thing that I thought I'd highlight this week.
Oh, thanks, Kit. I mean, it's criminal, really, isn't it? I mean, and it's definitely the case that an already brittle health service has just been taken apart by the added burden of COVID and all the other winter troubles that are happening, and this doesn't show any signs of stopping. So let's hope they can get on top of that. But talking of people not faring well, Professor Costello, back to our chair, I believe you've been looking at studies on life expectancy and inequalities. Is there anything you'd like to tell us?
First of all, there's a new report just come out from the University of Manchester, which is showing, not surprisingly, a lower life expectancy, higher infant mortality, and much worse health and well-being in the north of England, where I am right now on the east coast of Yorkshire. And that comes as no surprise. So the northeast, where I'm sitting, has about 3 years less life expectancy. I haven't read the whole report. That doesn't sound, well, it is quite a bit, 3 years. But one thing is the active life expectancy. When I walk around Bridlington, as I did yesterday, the numbers of people in their 40s and 50s who are on mobility aids, limping, smoking, hungry, poor, it's a very poor environment. And that's exactly why we're seeing a lot of that. And I think people will have to go in and look at this themselves. It should be in the newspapers. But there are a lot of people, more people in the north, limited by disability, who have bad or very bad health, much higher rates than in the south. Rates of economic inactivity that then adds to the hunger crisis that we're in, and many people more that have to provide unpaid care. One forgets about the carers. So that's in this country. In terms of globally, unequal vaccination continues. The latest figures show that only 3 out of 4 people in low-income countries have not received any vaccine. So 2.5 years after we've got a vaccine, we've still got a situation where the patents are held by big companies like Moderna and Pfizer, making hundreds of billions of dollars of profits. There's been no waiver for the patent. And so you can't produce this apart from their approved laboratories. And of course, it's unaffordable in most countries. So we have a global apartheid in vaccination, and that has not been solved by the World Trade Organization or WHO. Finally, just on WHO, I've been checking out what they've been saying, and I've been reading what Maria Vankakova, who is an old colleague of mine, she's an excellent epidemiologist who heads up the WHO show, if you like, for this. She says, we're still in a fake, the public health emergency of international concern. People are dying from COVID every day. People are suffering from post-COVID syndromes. Health systems are strained. Workforces are exhausted. We are in a better situation because of masks, PPE, ventilation, test treatments, and vaccines. But there are still 10,000 deaths a week officially reported. They did reach 40,000 a week just about 2 or 3 months ago. There are 6.9 million people dead worldwide, but that's only from official figures. And for example, we know in India that 531 million deaths are officially reported, but models suggest it's 10 times that figure. She says we have to maintain surveillance, sequencing, sharing data. We have to continue with all the individual measures like vaccination, masks, ventilation, clean hands, stay home if unwell, test and seek treatment, share and good information, help others. But she says governments need to still be vigilant. Do not dismantle systems, which we've been hearing about today. And you need to maintain systems because they have enhanced our ways of looking at other problems like influenza, as Sheena was saying. The vaccine work has come up with new vaccines for RSV, but also this is for Ebola, Marburg, monkeypox, chikungunya, and of course the next pandemic, wherever that comes from. And finally, she says we must tackle the infodemic. In other words, the disinformation and politicization of a lot of this. And finally, there's some reference that I think Tedros, the Director General, has slightly upset China because he said they should have shared some of their genetic data much earlier, which of course the Chinese refute. We also don't know how many deaths have occurred in China since the lockdown lifted, because blogs from China suggest that, they encourage people not to refer to COVID on death certificates. I think I'll stop there.
Thanks, Anthony. I think that's a stark reminder that living with COVID is really a position of privilege, and that applies both in this country in terms of socioeconomic and health status and across the world. And, what are we doing? It won't finish if we carry on like this. But without further ado, we've reached the end of our little summary. Hope you've enjoyed it. And I will actually hand back over to Anthony to chair the question session. Thanks, everyone.
Oh, thanks very much. That's great. So we've got some really good questions that have been sent in. No one's joining us, but I'm going to start with Margaret, who asks, how effective are lateral flow tests against the newer COVID variants, such as XXB? I've seen reports that they're only picking up a small percentage of cases. I think Margaret's a GP, by the way. She says, my patients are now frequently reporting that only one person from their household tested positive, although they all had the same symptoms. Or maybe they only tested positive on day 7 of the symptoms. Is there any evidence about this? Who would like to go on that? Steve.
Thanks, Anthony. I mean, there are changes in the N protein in some of these variants, but not probably extensive enough to mean that the antibodies that are present in those tests per se won't work. It's hard to know what those antibodies that are used in those tests are because they're proprietary, a lot of them. But the other aspect of this is that the Omicron variant viruses are so much more infectious and able to infect us that there's sort of a lower load at early times, and disease happens much more quickly for that lower load. So you don't always catch up with the detection, which, remember, you're directly detecting the virus in you rather than doing something like a PCR, which amplifies things. So it's a much more sensitive test. We already knew that about 20 or so % of the original strain viruses were missed by lateral flows. It's probably a bit more than that. And so the kinetics of detection are different. So it doesn't mean that it's not working. It means that your ability to spot the virus in that disease is changing. So what we need really is more sensitive lateral flow devices, which could be made if there was a will to do so, but I believe most of them have been scrapped. So yeah, it's really important to understand that, lateral flow tests are a red light test. If you're positive, then you are infectious. If you are symptomatic and you've been in contact with someone with COVID, chances are that's what you've got. So please do take precautions if you possibly can.
Sorry, Helen, can I ask, you're a busy GP. Is your experience similar to Margaret, that you're seeing households where maybe one gets tested positive, but lots of others seem to have the same illness? Or
yes, I think that's happening. I've also seen lots of patients with respiratory symptoms, and they've done a test on day 1 or 2, which was negative, and therefore they are quite convinced they don't have COVID. Because there's so much of it around at the moment, we've got 2 of our nursing staff off at the moment with COVID. We know there's lots there, and odds are that quite a lot of the people we're seeing who've got respiratory symptoms do have COVID, but they've tested negative. And it's really difficult to say to people, well, you need to test again, because if they've got to buy the tests, if they don't have easy access to tests, actually it's difficult to know what to recommend to patients in terms of how often, when in an illness, they should test.
Thanks, Helen, that's helpful. Next from Chris, how can we manage personal risk when so many methods of reporting infection rates have been stopped? Any information also about variant XBB 1.16, so-called Arcturus in the UK? Anyone on the data front? Steve, again, our resident expert.
Well, I won't speak about the data. Maybe Duncan can say something about that. And I think he actually did a really good summary of what's left earlier on. The answer is not a lot. So I've been speaking to people about this. The Arcturus virus is here. It's called XBB 1.6.1, if you want to call it its proper name. It's absolutely thriving in India and causing a massive outbreak. That much is clear. It is here in the UK, but it's only been detected at quite low levels. What is perhaps going a bit more quickly is the 1.9.1 and the 1.9.2, which are viruses that originated over in the States, and they seem to be coming over here and growing more rapidly. But we've got a real mix at the minute. There's still viruses that we had in the winter waves with us, and it's all over the place. So it doesn't seem as though this variant is rapidly out competing everything else as it did in India. And that's probably to do with differences in our vaccination rates and our history of infection that's giving us different immunity to this variant. So it's not perhaps thriving as much, or it may be up against different viruses. So it's really hard to compare between countries now. But if there was going to be another winner, causing the next wave, it would either be this one or the 1.9, I expect.
Duncan, anything to add?
Just to say, I think, tracking variants is a bit of another of the casualties of the ONS infection survey. So when we had this representative sample, we had a relatively good idea of the proportions of variants across the country, but we don't have that anymore. So we're just sequencing what we sequence. So the uncertainty is higher now. Yeah.
Okay, we've got another question, which is interesting. It's from an anonymous person, but nonetheless important. I'm vulnerable and pregnant and have had 4 COVID jabs. I'm not eligible for an April booster. I'd like to know if I breastfeed, will my COVID vax immunity be passed to my child? Is there an argument for breastfeeding for longer to help protect the baby for longer? Anyone? Sheena.
I can certainly talk a little bit about what we've been learning about vaccination in pregnancy, because I think the initial studies were really focused on whether the vaccines were safe for pregnant women and obviously their babies, but they weren't really asking the studies about what happened with the baby in terms of the baby's protection against COVID. And now those studies have actually happened. And of course, these are important because when you're born, your immune system is really immature, it's still developing. And this does actually leave babies very vulnerable to COVID. So they looked to see whether vaccines, and particularly boosters given during pregnancy, so this is a slightly different situation, did protect the baby. And it did show that there was a 53% effectiveness compared with no booster. but the protection did wane as the baby gets older, and there was no additional protection after around 3 months of age. Now, if you're not eligible for another booster, you won't be getting that additional hit. So we just have to hope that you are getting that protection that you're passing down. And yes, you should be passing some protection just from what we know fundamentally about the protection that you confer through breastfeeding. You pass on IgA, which is a type of antibody, and a little bit of IgG, another type of antibody. So you may well be passing on some protection, although we know that our antibody levels do drop after vaccination. So it's very difficult to sort of say that, but it certainly seems that this might have some role in helping. It also really raises important questions about what we should be advising around vaccination and boosters in pregnancy and how late we should be giving them. Perhaps we should be looking at advice around the 3rd trimester. But I think I can't really give you any more personal advice than that.
I looked up some of the data just to get, this was from a study from a couple of years back, so I haven't seen updated, but most young babies, although they're generally more vulnerable, they're only about 1 in 2,000 babies with any confirmed COVID infection ended up in hospital. In the first wave, I think only 66 babies under the age of 1 ended up in hospital. There is a slightly higher risk of newborns getting the multi-system illness compared to older children, but they are lower at risk, it would seem, of becoming infected. Perhaps because, and I'm not an immunologist, I'm very nervous about saying this, but because the receptor that the virus binds onto is much less present in newborns. So we need to get this in perspective that, the fact that you've got 4 anonymous, you've got 4 vaccines on board, you are breastfeeding, there will be some antibody transfer the longer you breastfeed. Your risk of your baby having a problem is very, very low. Is that fair enough?
I think Trish has something to add.
Trish.
Yeah, no, I'm just putting on my GP hat. Look, the question of whether and for how long you breastfeed your baby is a very personal one. It's quite complex often, whether if you're going to work, whether or not you're able to express, all those kind of things. But also, let's not forget that we're talking about COVID at the moment, but when you breastfeed, your breast milk contains an awful lot of good things, lots of antibodies against other diseases. And so, just reiterating, if you can and if it's comfortable to breastfeed, then medically that's usually a good thing. But also there are a lot of personal choices, and women who choose not to breastfeed or find they can't breastfeed, there are also lots of other ways of being a good parent, shall we say.
Thanks very much, Trish. Let's go on to the next one, the other end of the age spectrum, from Catherine Davis. I am 82 years old and being advised to have a 5th vaccination, but I'm very concerned at current research demonstrating the high incidence of adverse reactions from the mRNA vaccines. What's your opinion on the risk-benefit balance currently for 82-year-olds? Risk benefits of mRNA vaccines. Sheena, you're not muted, so I'm going to come to you.
I think we've talked a few times about the evidence for the risks in mRNA, and unfortunately there is a lot of misinformation and disinformation circulating that make the risks sound a lot bigger than they actually are. And the data is showing really quite overwhelmingly that the vaccinations are safer than having COVID themselves. We've done quite a lengthy debunking document about mRNA vaccines that goes into individual kind of questions and myths around this particular vaccine platform. There are a number of different vaccines that are being offered in the booster. So there's 2 types of mRNA vaccines. These are with, I think it's BA4 and BA5, so they're bivalent again. There's also a vaccine that's using something from the beta strain, which is an older strain of COVID vaccine. That's a protein one. So that is another one that might be getting offered. And there's another protein one that if those three aren't offered, this one might be offered instead. So there's actually a few different vaccines. You may actually not even get an mRNA vaccine, but as far as we know, the research is really, really supportive. And what we do know about older people is that their immune system, it tends to decline more. So they are, and you unfortunately are amongst the most vulnerable, because your immune system, you've got less of the white blood cells, the T cells and the B cells, and the B cells make antibody. And so you do need a few more reminders from boosters to keep you topped up and as protected as you can be.
Thanks very much, Sheena. That's really helpful advice. Let's go on to the next one from Vicky O'Malley. Really interesting. I certainly don't know the answer to this. What is the panel's opinion on the likelihood that COVID infection, repeat infections, or even long COVID will be shown to cause a reactivation of cancer in remission, the acceleration of an already active cancer, or a new cancer diagnosis? We don't have Leonard, our resident cancer expert, with us today, sadly, but who would like to take that on? Trish, you've unmuted.
Yes, this is a really interesting one, because when I was doing my general practice, every other week someone would come in and say, look, I've read this thing, doctor, that such and such causes cancer. And the thing about cancer is that it's caused by bad luck, basically. A lot of things coming together, your genetic makeup, the lifestyle you lead, the food you eat, perhaps some environmental thing that's got into you. But someone else with a very similar combination of those risk factors doesn't get cancer. So it's when you say, does something cause cancer? Even we've all known people who've smoked like a trooper and not got lung cancer, when we clearly know that smoking causes lung cancer in some people. So that the question about causing has to be a bit, subtle. Now, I took a look at the literature, and I'm not a cancer expert. As I say, I'm a GP, so this is a generalist answer. There is not a massive signal from the vast number of papers that have been published that suggests that any particular cancer is dramatically reactivated or caused by someone getting COVID. But then we all know it's very difficult to tease out that stream of causality from all the other things that have been going on, because all sorts of things tend to change at the same time, and it's not the sort of thing you can actually do a controlled experiment on. So I think the question of whether it might hypothetically do something to your immune system is not something for me to answer, but certainly whether COVID causes cancer, there is no good evidence that I know of. And now I'm going to hand back to the experts in cancer immunology who are also, Sheena, you look like you might know something about this. She's shaking her head. Steve's got his hand
I think
up.
it was Steve that was looking knowledgeable, not me.
Yeah.
Well, yeah. So as Trish rightly said, cancer is multifactorial and comes down to luck. Your chance of getting cancer increases with age. And cancers invariably take a long time to arise. And that's whether or not you have an infection with a known, what we would term an oncogenic, so a directly cancer-causing virus, such as papillomavirus or Epstein-Barr, hepatitis C or B. They are well known, but even some of those well-known viruses took a long time to show that they were directly associated with cancer, because the fact is, much like Trish's example of smoking, not everyone that's infected with that virus develops cancer, because it's kind of the first step tipping you over that balance towards your DNA accruing more and more problems, which gives rise to cancer. So I think for a start, it's too early to tell. You would have to have either multiple repeat infections or a very long-term infection in part of your body where cancer might arise. I don't think there's good evidence that happens for a prolonged period, although it may do in some immunosuppressed people, for example. But I do think that there are going to be other environmental factors that are far more likely to cause cancers. And certainly this sort of short-term aspect of this, I think, weighs against the idea that this virus is going to be directly oncogenic. And there are no known examples of other coronaviruses in nature that are oncogenic at all, as far as we know from animals.
Thanks, Steve. That's really helpful. Having said that, I mean, with so many infections around, a lot of people being treated for cancer will get COVID, and presumably some of those will get long COVID. So it's going to make their life more miserable, but it may not be in any way related to their tumor as such. Is that fair enough?
Yeah, I would certainly say that. Yeah.
Yeah. Listen, thank you very much. We are at time. We had two other questions about adrenal insufficiency and why Richard, who wrote in, said he didn't get any colds these days. Was it related? But we'll come back to those next week because we are at time and I need to chair this properly. So huge thanks to Sheena and Steve for putting these questions together for the experts. I hope you've learned something, because I always learn something on these things. It's really useful to get because none of us can cover all bases. So thank you for joining us. We're now having briefings for 2 continuous weeks because we missed last week. So there will be a meeting next week, same time, same place. Till then, keep safe. Bye.
See you, folks.